One of the first steps in race car design is developing a solid foundation for your suspension geometry. I've seen this to be especially challenging for FSAE teams when they're just starting out. A lot of times there isn't a clear understanding of how critical a well-designed suspension really is to the performance of the car. That's exactly why I created this software. It allows you to define suspension hardpoints based on intuitive inputs without needing to worry about complex calculations happening behind the scenes. The software handles all of the geometry math for you and generates hardpoints that make engineering sense. One of the most powerful features is having the ability to export those hardpoints directly to SolidWorks. If you go to Files and then select Generate Files, you can create the suspension macro. From there, you can open SolidWorks and go to Tools, Macro, Run, and click on the suspension macro SWB. It'll always save to your desktop. Open it. This will display all of your suspension points, including push rods, tow rods, steering links, and wishbones. I'm going to hide a few of these just so you can understand what's going on here. So here's our wishbones and our ride height plane. The ride height plane is defined by this 3D sketch, and the ground plane is defined by the top plane. If you're trying to figure out which side is the front of the car, you can always click on the origin, and the front of the car will be defined closest to the origin. So on this left side here, we'll see the front of the car. Another important aspect of this workflow is how it supports teams that carry the same upright design from year to year. As long as the team knows the dimension that defines the kingpin axis, that value can be input directly into the software. And the distance generated in CAD will be exactly that dimension. This means there's no need to completely redesign the uprights each season. So I'll go ahead and measure these uprights here. So the distance from the upper and lower kingpin points is exactly 10 inches. And if we go to the software, we can see that the input for the kingpin span is exactly 10 inches. This gives you a clear visual base for building your suspension and understanding where your uprights and tires will sit in 3D space. That's how you open the hardpoints in SolidWorks. Another major feature of this software is having access to the CalSpan tire consortium data. As you change parameters, the software calculates the F sub Z value, the vertical load on each tire. Depending on whether the car is cornering, braking, or accelerating, it references different slip angles and uses those conditions to determine the corresponding force and moment values from the tire data. From this, you can also view the link loads for each corner of the car. This gives you valuable insight to how forces are being transferred through your suspension system. You can also view the camber curve, which is directly based off your suspension geometry. For example, if I change the front roll center height to 2.5, you'll see that the camber curve has changed accordingly. So if I go back to 1.5, you'll see it goes back. This shows you how your tires will behave in roll and bump, which is critical for predicting handling behavior. If you know the amount of roll or bump your car will experience, this tool gives you the meaningful feedback on how your tire contact patches will respond before you even start building physical components. There's also the outputs from points window, which is useful if you already have existing hardpoints. You can input those here and the software will compute the resulting parameters. Caster, camber, roll center, scrub radius, track width, and more. And you can also export and load a CSV. And you can also export these points as a macro file as well. And that's essentially the workflow. If you have any questions or need help getting started, feel free to reach out. I'm always happy to help.